Let's begin with question number 1 on this paper. All right. Okay, let's read it and move it to a whiteboard, please. So find the values of k of which the line y equals to kx minus 2 meets the curve y square equals to 4x minus x squared. Okay, let's do this. So the idea is we must understand that we substitute, okay, or substitute one equation, given equation into another. We are finding the intersection points. That means we are assuming that the intersection points exist. Okay, that's the general idea, because that means the y and x on each of these equations are the same, because y and x are generally right. So when you are assuming substituting this y into the other equation, that means you're saying both y's are the same. If both y's are the same, and this is a curve and this is a line, that means the both y's are only same at these 2 points, which are the intersection points. But the thing about the intersection is there are 2 types. Here they use a bit of a more general word, if you notice carefully, because it can meet in 2 ways. That means it crosses it in the 2 intersection points. But at the same time, it could have only met at 1 point. That's called tangent point. So here it's not so clear. They just say meets the curve. So we must assume that either one of these cases is happening. So for this case to happen, the case 1, the discriminant of a quadratic must be bigger than 0. That means the quadratic formed by the simultaneous equation. And for this to happen, b squared minus 4ac must be equal to 0. So combining these 2 facts, so that is why we need to do the discriminant of this resulting quadratic equation to be bigger equal to 0. Okay, that's the theory behind it. Okay, with this question, how to solve this question now. Okay, so let's take a look at the calculations first. Okay, let's put in a box and let's begin. So that means now I substitute in this the y. So on the left hand side it becomes kx minus 2 like that, whole thing square. From here, please take note. Then this is 4x minus x squared. Let's expand it out, please. So k square x squared minus 2 minus 4kx plus 4 equals to 4x minus x squared. So to reduce error, it's good to just, expand like that first. Then we bring all the terms to the left-hand side in order. That means the x squared term first, followed by the existing term, and then the moving term. So positive 4x minus 4x like that, plus 4 equals to 0. Then we want to factorize accordingly. So k squared plus 1, and we factorize the common x squared. And the next term, we want to factorize the kx, the x respectively like that. So minus 4 I take out. Then I realize the k plus 1, and then x. Minus 4, k plus 1, please take note. This is the factorization substitution. So plus 4 equals to 0. From here now, we can deduce that a is the coefficient of the leading term x squared. So a is k squared plus 1. B is the coefficient of x with the sign, so minus 4k. Easier to write. Either you can put like this, the factored form, or multiply out, doesn't matter. C is 4. Okay, so one last calculation here, which is we need to do the theory that we talked about. So for it to meet the curve, either it intersects at 2 points or tangency point, at 1 point it meets. So there are 2 possibilities. So we combine the possibilities. So b squared, so negative 4k plus 1 like that, b squared minus 4 a k squared plus 1, 4ac, c is 4, bigger equal to 0. So by reducing this further, we should get the answer. Please take note that here got 16 like that. This is k plus 1 square. Here also got 16 like that, k squared plus 1, bigger equal to 0. So just 2 16s you can just cancel out because you can factor them out. I mean, just 2, because 2 terms only minus, meaning that after factoring and cancelling, so we just write like a shortcut straight away. something like this. Okay, now let's expand this part, please, and complete it. Oh, so this is k squared plus 2k plus 1. This one just multiply out, minus k squared minus 1 big equal to 0. From which now we can deduce that k squared minus k squared is gone. And then the plus 1 minus 1 is gone. So only we're left with 2k big equal to 0, dividing which by constant, the sign doesn't change, positive constant. The answer will be k is bigger equal to 0. Thank you.